Suppose P of n be the statement 2 raised to the power of n is greater than or equals to 3n. We need to show that P of n plus 1 is true whenever P of n is true. Okay, let us begin. So here we have the statement. So we're going to rewrite the statement. We have the statement P of n such that 2 raised to the power of n is greater than or equals to 3n. So this statement is true. So is a true statement. This is given to us. Now what we'll do, we'll have to show that using the statement, we can show that P of n plus 1, this is also a true statement. In other words, what we'll need to do here is we'll need to show that P of n plus 1 such that 2 raised to the power of n plus 1, this must be greater than or equals to 3 times n plus 1. Okay, so how shall we do that? So what we'll do, we'll use the statement that 2 raised to the power of n that's greater than or equals to 3n. We're going to multiply both sides with 2 such that we have 2 times 2 raised to the power of n that's greater than or equals to 2 times 3n. Now 2 multiplied to 2 raised to the power of n, so that's 2 raised to the power of n plus 1. So this is going to be greater than or equals to, so 2 times 3n, that's 6n. Right. So 2 raised to the power of n plus 1, so greater than or equals to. Now what we'll do, we're going to split 6n as 3n plus 3n. The reason why we split this into two parts, because what we'll do, we're going to work around this second term, that's 3n here. Because we have everything that we want to show, because we have on the left hand side 2 raised to the power of n plus 1, that's matching. On the right hand side, we need 3n plus 3. We already have a 3n. So the idea that we will be using here is we want 3n to be greater than or equals to 3. Now first we have to make sure that this is indeed a true statement. Now we know that n here represents the set of, n is a natural number here. So what is the smallest natural number? We know that the smallest natural number, that's 1. So if we use n equals to 1, this is always going to be a true statement. 3 is always going to be greater than or equals to 3. In other words, what we are saying here, that if 3n is greater than or equals to 3, then it must be true that 3n plus 3n, so this must be greater than or equals to 3n plus 3. Fine. So in other words, what we have here is 2 raised to the power of n plus 1. So this is going to be greater than or equals to, we have already said that 3n plus 3n, this is greater than or equals to 3n plus 3. So let's write it down so that it does not create any confusion. So this is greater than or equals to 3n plus 3. And finally, what we can say here, that 2 raised to the power of n plus 1. So this also comes out to be greater than or equals to 3 times n plus 3, or in simple words, 3 multiplied to n plus 1. So we have successfully showed that the statement, hence the statement P of n plus 1 is true, provided P of n is already true.